Who's that?
Wake up.
Hi, everyone.
Wake up.
Yeah, Amy D. They're telling you to get up.
Wake up. Easy too.
No, but that's okay because I have a lot of room now.
Let's meet it.
What?
This is like the funnest class, you know?
Yeah.
It's
I
so.
know, without that, huh?
It's.
It's okay. They'll probably
That was Chanel. Oh my goodness. Okay, increase and decrease. Happy Friday, y'all. All right, let F let F be a function defined on an interval. Let's call this interval I. And let x subscript 1 and x subscript 2 be any 2 points in I. Okay, so mind you, I is the interval. Increase and decrease. This is just a review of last year. F increases on the interval I if x1 is less than x2 and f of x1 is less than f of x2. Okay, so that's increasing. So what do I mean by this? Let's sketch, because I'm a visual learner. Okay. x1, x2. So look at that. Is x1 less than x2? Yeah. So I'm going to sketch something out, something basic. Like that. Is f1 less than f2? Sure, right? The y value at x location is smaller than the y value at the second location. So that's why from x1 to x2 that will call a what? Increase, right? Okay. Similarly to decrease. F decreases on I if, again, x1 and x2 are just locations. So x1 is always going to be smaller than x2 for this definition. So f decreases on I if x1 is less than x2, and all we do now is flipping these guys at the end. F of x1 must be greater than f of x2. So a sketch for this would be, so here's x1. Remember, x1 is smaller than x2. And it's saying that, okay, for it to be decreased, y at the first location has to be bigger than y at the second location. So increase and decrease. That's what we did in Algebra 2. Now, how is that going to help us in calculus? Corollary. I can't say that fast, because if I say it fast, I'm gonna say like Corolla. Corollary. Corolla is a type of car. Corollary. Huh? Yeah. Okay, increasing and decreasing function. Like I said, I have to say that really slow. Like there's like words I would say so like logarithm. I have to say that slow, otherwise I'm gonna be like la 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 what? You know? Okay. So corollary. Oh, see, I'm eating like I'm kind of swallowing down here. So increasing and decreasing function. Let f be continuous on the enclosed interval a all the way to b, and differentiable on open interval a to b. So this is sort of backing up the definition of increase and decrease. If f prime is positive, meaning that it's bigger than 0 at each point of A to B, which is the open interval, then f increases on the closed interval A to B. So let's sort of look at our drawing, because we already have the drawing. F prime is really talking about the derivative. Would you guys agree? If the derivative is positive, then by definition, this, it's increase or decrease? Increase. So let's look at the purple drawing. If I want to take the derivative of that, positive or negative? Positive, right? So that backs up this definition. Now, if I were to take the derivative of the red curve, positive or negative? Negative. So therefore, same definition here. If the derivative is less than 0 at each point, then you take out the word increase and replace with decrease. If f prime is less than 0 at each point of A to B, then f decreases on the closed interval A to B. So this definition, guys, is using a bracket for increase and decrease. Can you guys see that? It's really optional. Okay, you can technically use parentheses for increase and decrease. But for this book, your book's definition is using bracket. So if you want to be consistent with your book's answer, then keep it as bracket. But on your AP test, I'll take either one. Example quattro. Can you please help me, Ryan, help me read the instructions for example 4.
For each of the following, use analytic methods to find A, the local extrema, and B, the intervals on which the function is increasing, and C, intervals on which the function is decreasing.
Perfect. Okay. We all by now know how to find the extremes, right? Okay. What do we do first to find the extrema? Derivative. G prime of x equals, can you please, Marco, give me the derivative of g?
2x minus 1.
Good. We're going to take it and we said equals to 0. Find the critical point. So, Aiden, go ahead and solve for it, hun. What is x?
0.5.
Good. X is 0.5 or a half. We only have one critical point. How do I know it's max or min? What do we do next? Plug it back in? Yeah, plug it back to the original. So g over half equals quantity half square minus half minus 12. Go ahead and work that out. Give it to me in exact form. Okay, so give it to me in fractions. So Trey, whenever you're ready.
I know the decimal form, is that okay?
Sure.
Okay, 12.25.
12.25.
12.25. Yeah.
Yeah? Positive, negative?
Negative.
Negative. 12.25, aka negative 12 and a quarter, aka negative 12 quarter. I said a quarter, I wrote half. Aka negative 49 all over 4. Any one of those is perfect. Okay, I'll take it. All of them. Any of them. Now, I normally do a number line. By the way, anyone does a number line besides myself? A few? Okay. You don't have to, but. So when at x equals to 1/2, the y is negative. Would you guys agree? So somewhere down there, there's only one dot. How would you know that dot's a maximum or minimum? Or sometimes, if it's an inflection point, it's neither. What do? Yeah, so endpoints. As x approaches positive infinity, what's happening to g of something ginormous? Positive or negative? Positive. as x approaches something super large on the negative side, like g of a negative 100, positive, negative, also positive. So that means it goes up like that, right, y'all? So tell me the answer. How would we write it? Absolute min, absolute max, none. Absolute min is negative 12.25 at x equals to 1 over 2. So that's not new. Now, the new piece is finding the interval where it is what? Increasing and decreasing. Now, mind you, this example was really easy. So even looking at it, can you find the increase and decreasing interval right away? Yeah. But not all the time that is this easy. So we'll go through the motion to make sure we know how to do for the more difficult ones. Normally, when you guys are looking for increasing and decreasing interval, what you want to do is use the critical points. And then I'm going to put plural in parentheses because sometimes you only have one. Use the critical points and find f prime of x. Okay. Remember, how do we know if a function's decreasing or increasing based on the derivative? We just wrote the definition down. What's the definition for increase? What must the derivative be? Yeah, positive, right? F prime is going to be bigger than 0. What would be then the definition of decreasing? F prime is less than 0. Okay, so all you're doing is finding the derivative, plug it in. So I'm also, again, going to do my number line. But this time, I'm going to plug into my derivative function. Why am I going to plug into my derivative function? To see if it's positive or negative, bigger than 0 or smaller than 0. I already have my critical point from the first step, so it's immediately a half. Okay? So now, because I don't have any other critical points, I'm going to use the endpoint. As x approaches something ginormous, g prime of, let's say, 100 is what? Remember, we're using g prime, which is like over here that you found. Or in this case, I think Aiden found it. What is it? Positive, because it's true or false? Yeah, so this is side's positive. How about as x approaches something super large on the negative side, like g prime of a negative 100? Positive or negative? Negative, right? So this is negative. So this is negative on this side. So from looking at the number line of the derivative, can you tell the increasing and decreasing interval? Yeah, so what's increasing from where to where? Increasing from inclusive, a half all the way to infinity. And again, the bracket, you can also use parentheses. It's okay. Then part C is asking the same thing except decreasing. Decreasing from negative infinity all the way to what? Half. Okay. So the work is the same for increase and decrease. Let's try B. B is probably our last example today. What do you guys want to do first? Derivative, right? Find the critical points. Both increase and decrease and min and max would both need a critical point anyway. How are we going to do that one? What rule? Yeah, here we go. G prime. All right, U prime. What's U prime? 1/3 times x, good. To the power of negative what? Yep, times u, which is just x plus 8. Add. What's the derivative of x plus 8? 1. Okay, so times x to the 1/3. Let's make it pretty. Okay. So this one, I have 1 on the top. Actually, x plus 8 on the top. Is that okay? On the bottom, I have 3 cubed root of x squared. Yay, nay, maybe? Yeah. And this one, on the top, I would just have cubed root of x. Is that okay? Let's find the common denominator. What is it?
3 cubed root.
3 cubed root of x squared. Yes or no? What you multiply to the bottom, you multiply to the top. All right. On the bottom now, we have a common denominator. So that is bottom, 3 cubed root of x squared. Did the top get any prettier or no? It's trying to get ready for prom, you know. Did it get any prettier? Is it helping out with this and that? Cube root, what did that turn out to be? Just an x, right? Yeah, root x. So we have an x plus 8 here. Over here, I now have 3 times x. Yes or no? Okay, so how many x's do we now have? 4 x's plus 8 all over 3 cubed root of x squared. Looks pretty pretty. It's ready for prom. Okay. How do we find the critical point, y'all? Set equals to 0. Immediately, let's find the x value that cannot be. What is it? 0. That's one of the criticals. We have one critical point going. The next one, we're going to take 4x plus 8 and set it equals to 0. Our next critical point is at -2. So we have 2 critical points. Go ahead and plug it in the f function. F of 0 is, what's f of 0? And then f of -2. Plug it in and I'll just call on one of us to give me the outputs. So Lauren, whenever you are ready, give me the output for 0. 0. Yes, ma'am. And Mr. Ross, whenever you are ready, give me the output for -2.
6 cube root of -2.
6 cube root of -2. Class, if you have a cube root of -2, you might want to do what? Simplify that out to -1. Cube root of -2, that's like cube root of -1 times +2. And cube root of -1 is -1, and take it out in the front. Okay. There you go. Okay, let's draw a number line. Let's see where these guys are. So this is original g of x. I have 2 x locations. One's at 0, one's at -2. At 0, the output was 0, so it's right there. At -2 was a negative value, so it's below it. Somewhere below it. It's not important where. Now we have to analyze. As x approaches something ginormous, let's call it like 1,000. What is g of 1,000? Positive or negative? Positive. 1,000 to a third root times something ginormous is positive. So it goes up like that. Yes or no? And then as x approaches -infinity, positive or negative? Negative? Let's see. I have to verify. Negative number to the third root, that's a negative answer. Would you agree? -1,000 plus 8, that's also negative. A negative times a negative is a positive. So that's positive. So fix that sign. So that's like that. So if I were to sketch this out a little bit like that, okay, what does that look like? Is it a parabola, really? Okay, well, let's see. Well, for sure, I know right away, do I have an absolute min?
Yes.
Yeah, okay. An absolute min is where? Yep, is -6 cube root of 2 at x equals to -2, right, y'all? What do you call the 0.00? Is it anything? Does it fit the definition of min and max? Are the two numbers, remember, min means just like this. On both sides of it, it's bigger, right? Max means both sides lower. Does it fit the definition of min or max?
No.
No. So therefore, there's nothing. 0 doesn't function. Let's go to B. See, like, that's why I give you so much space. I'm already, like, done with half of my page. Okay. B said just give me the increase and decrease. B and C are the same. Just one's increase, one's decrease. We got the derivative already, right guys? So I'm just going to copy it over. Here's B. The derivative was on this side 4x plus 8 all over 3 times cube root of x squared. Just copying over again. We found the critical point already as well. True or false? There are 2 critical points. It was at x equals to 0 and negative 2. Okay. Again, because it's just our second question on increase, decrease using derivative. Remind me the definition of increase again using derivative. F prime must be greater than 0. Decrease means F prime must be less than 0. Okay. And what that means is I'm going to draw out the graph, a line graph of F prime. In this case, I'm using G prime. All I'm interested in is just negative and positive. Okay. So we're just going to pick points and tests. Let's do the endpoints first because those are always easy. As x approaches negative infinity, okay, G prime of something negative 100, positive, negative. So let's see, I have to verify. On the top, positive and negative. Negative. On the bottom, it's always square, right? So the bottom's positive. So the top's negative divided by positive. So that's going to be, I'm sorry, the top's negative divided by positive is? Negative. So this right here is negative right there. So that's a decreasing interval right there. I'm going to go all the way to the right because for me, end behavior is always easiest. G of a positive, something ginormous. Positive. Yes or no? Now I just have to test something in between. What do you want to pick in between that's super friendly? 1. 1 sounds good. X equals 1, so G of 1. And again, all I'm really looking for is positive or negative. On the top, when I plug in 1 for the top, positive or negative? Positive on the top.
Should be negative.
What?
Negative.
Oh, yeah, negative 1, thank you. Negative 1. So when I plug in negative 1 on the top, positive or negative? 4 times negative 1 is negative 4 plus 8. Positive at the bottom. When I plug in negative 1, positive. Positive divided by positive is always positive. All right, let's write our increase, decreasing interval. So B says increase, so increase from where to where? Negative 2 all the way to infinity, right guys? And then C is just the same thing, except it's just said decrease. Decrease from where to where? Negative infinity all the way to negative 2. And that is an egg roll.